In this tutorial, I'm going to use the Gram-Schmidt process to determine an orthonormal basis for the subspace of R2 spanned by the set of vectors 1, 2, and 1, 1. So given those two vectors, I'll start by looking at the first one there, the 1, 2. I'll call it V1. Then for the second vector there, the 1, 1, I'll call it V2. What we are looking for in this case is vectors U1 and U2, which have a norm of 1 and are orthogonal. So the first step there is now to normalize V1. To normalize V1, I will set it to be equals to U1, which is equals to V1 divided by the norm of V1. Our V1, we are saying is the 1, 2 there. So I'll write my U1 is equals to V1 divided by the norm of V1. For the norm of V1, it is the square root of the inner product of V1 and V1. We multiply the corresponding elements, 1 times 1 plus 2 times 2, which gives us 5. Then we would have 5 under the square root, so we would have square root of 5 as the norm of V1. In the formula there, we are dividing V1 by the norm of V1. So we are dividing now by the square root of 5, so we would have 1 divided by square root of 5 times the vector 1, 2. I can now go on and divide the elements of the vector V1 there by the root 5, so that would have 1 divided by square root of 5, 2 divided by square root of 5. So that's our vector U1 there. We can now go on and look for U2. The U2 is equals to W2 divided by the norm of W2. The W2 is equals to V2 minus the inner product of V2 and U1 multiplied by U1. Our V2 is the 1, 1 there. The U1, the one that we have just obtained, this one here. So I'll evaluate my inner product V2 dot U1. So the inner product of V2 and U1 is equals to 1, 1 dot 1 divided by square root of 5, 2 divided by square root of 5. Multiply the corresponding elements, then add them. So we'd have 1 times 1 divided by square root of 5 plus 1 times 2 divided by square root of 5. This will give us 3 divided by square root of 5. The W2 there we said is V2 minus the inner product of V2 and U1 multiplied by U1. So I'll write my W2 there. And we are saying that our U1 is this one. The V2 is this one here. The inner product of V2 and U1 is 3 divided by square root of 5. Substitute the highlighted parts into this formula for W2. Then we'll have 1, 1 minus 3 divided by square root of 5 multiplied by the vector 1 divided by square root of 5, 2 divided by square root of 5. Now looking at this part here, I can multiply that vector there by the 3 divided by square root of 5. So for the first part, it will be 3 divided by square root of 5 times 1 divided by square root of 5, which will give us 3 divided by 5. And the other part will give us 3 times 2, 6 divided by root 5 times root 5. So it will be 6 divided by root 5. So we can simplify that to 1, 1 minus 3 divided by 5, 6 divided by 5. So that part, the 1, 1 minus 3, 5 over 6, 6, 5 over 6, it will give us 1 minus 3 over 5. It gives us a 2 over 5. 1 minus 6 over 5, it gives us minus 1 over 5. So our vector there becomes 2 over 5 minus 1 over 5. What we are having there is W2 is equals to 2 over 5 minus 1 over 5. Our U2 there, we are saying is W2 divided by the norm of W2. So for the norm of W2, it is equals to the square root of the inner product of W2 and W2. And when you evaluate that inner product there, it will be 2 over 5 times 2 over 5, which gives us a 4 over 25. Then minus 1 over 5 times minus 1 over 5, it gives us 1 over 25. So when you add them, we would have 5 over 25. 5 over 25 simplifies to 1 over 5. And when you take the square root, we would have 1 divided by square root of 5. Our U2 there, we are saying is W2 divided by the norm of W2. Our W2 is this one here. Our norm of W2 is 1 divided by square root of 5. But in the formula for u2 there, we are dividing by the norm of w2. So when we divide by the norm of w2, we would have that the 1 divided by norm of w2 is equals to square root of 5, because we will infer that since it's 1 over square root of 5. So when I substitute the highlighted parts there, we would have square root of 5 times the vector 2 over 5 minus 1 over 5. And I can multiply throughout by the square root of 5, so that we have 2 square root of 5 divided by 5 minus square root of 5 divided by 5. So that's our u2 there. And the u1 and the u2 that we have there, they form the orthonormal basis. So what you are saying is the orthonormal basis there is the set of vectors 1 divided by square root of 5, 2 divided by square root of 5, the second vector, 2 root 5 divided by 5 minus root 5 divided by 5.